5 clauses, you can create and basically manages the different database objects, right? So the primary objective of DDL expressions, DDL clause to control the definition of any database object, right? So we have actually explored or discussed how different databases can be created and different structures of tables in a database can be created, right? So we have taken 2 or 3 cases. So cases like creating a simple table without any constraint, creating tables with some constraints, and creating a specific table with 2 attributes as a part of primary key, right? So these are the basic expressions which you can create, which which we can execute in a SQL editor. Now we are moving towards a new specific concept called a foreign key, right? So like in the like I think in one of the class we have taken the definition of foreign key, right? So foreign key is a kind of constraint. It is again helping you to achieve some kind of uh, uniqueness between 2 tables or 2 database tables, two relational database table basically. So whenever you want to have some kind of relationship between 2 database tables or maybe between 2 entities, so to control a relationship and control its cardinality, cardinality means number of occurrences, you need to have some kind of concept. So again, this foreign key concept is used to maintain a level of uniqueness, kind of uniqueness on the two attributes which are existing or defined in the 2 different database tables, right? So this is what the basic definition we have taken. Now, if you want to create a foreign key, right? If you want to create a foreign key, you will be writing like this is the typical syntax: create table, student, right? First name, roll number, D number, and primary key on roll number, and after that we will be adding this expression: foreign key, D number, references, and then so department D numbers. It means so we have actually initialized the attributes on the student table. So if you can carefully see in the student table, which is a table, which is your child table actually. So because whenever we compare or whenever we thought of a concept of foreign key, there will be a database table which will be acting as a parent table. So parent table will be a table or database table which will be in the side of one cardinality. So if you can recall, in the previous lectures we have discussed that between two participating tables or relationship entities, one will be acting as one side, one will be acting as the m side, right? Likewise, so whenever we have this 1:m relationship and we need to implement or we need to configure this foreign key concept because of this 1:m relationship, we will be considering a database table which is in one side as a parent. Now, so our case, we are creating 2 database tables. We are creating now the student table which is m side. M side means we will be adding a attribute D number which is referencing to the department's D number, because department table is a parent table. So here you can see in the definition of, so now you are creating the definition of a student table. So we had it create this is student table, then its attribute first name, the roll number, then D number we have added, right? So D number is the attribute. Now after this we have defined primary key as roll number. That's one part, right? And after that, with comma here, we have added foreign key D number. So this D number is of student table, right? So this D number is of a student table, right? So this means we are trying to create this D number as a foreign key. This is what means, right? Now, if we initialize this D number as a foreign key, naturally, if it is a foreign key, it must be having some reference. So we are defining its reference. So now foreign key D number is references to the department number attribute. So this is what we are trying to say, that whenever we are having this parent-child relation in the child table, like in a student table, we are defining this D number as a foreign key, and it will be referencing to the department table and its department number attribute, right? So this is the typical expression for uh, defining or initializing any attribute as a foreign key, right? So this is a typical syntax of writing a create statement to create a database table where we have these two clauses, primary key and foreign key. Now, if you write this whole in syntaxes correctly, right? So there could be possibly we have error, right? There could be a possible case that you might get an error because we are assuming that department table is pre-existing, right? Because whenever we initialize a foreign key expression in a create statement, you should be making sure that this department table is existing. It has been created previous to this statement. And if it is not, if the parent table, this department table is not existing, this expression, this whole expression will might be causing a error, right? Error. So let's note down due to the of parent department table, right? And if it is available, if it is already created by some previous users, BDTP. Okay, let's rectify later on. Okay, so that is the only possible case. If a parent table is not available, parent table is not available. That is the only possible case where we could have a small error, right? In this previous expression, right? So that is the only possibility. Now let's move and try to create a department. So with this expression, create table department name department, and then everything is smoothly created, right? And after that you can simply execute this statement. So now it will work finally, right? So both database tables will be created using appropriate constraint, right? So we have now successfully seen that we could be having foreign key constraint on a database table, right? And the advantage of foreign key is whenever we will be going to insert some data records on the d number attribute, this d number attribute of student, it will follows the domain of the parents table and its attribute which we have mentioned in the reference part, right? That's what the typical syntax, right? So I hope till this point things are clear to you. Now you should be having this clarity on basically what is the use of foreign key, right? And what is the implication of imposing a attribute as a or defining attribute as a foreign key, right? So whenever we define this foreign key, sometimes it is referred as a referential integrity. So referential integrity means you will be having some kind of reference, and with this reference relation you will be controlling the values, right? So till this point things are clear. Okay, so I'm using that we have not any query from your side. Okay, now let me share again. So naturally, whenever we are saying that we have defined a foreign key relationship between or maybe referential integrity between these two tables, these two database tables. Now, what is the positive effect of it, and how we can control these values, and what is the other limitation we will face? So let's assume again student and this department scenario, right? So naturally हमने कहा कि we have initialized this foreign key attribute, and it is referencing to the base parents attribute. Now let's assume a scenario that due to some reasons, uh, okay, so let's assume first this that we have successfully created this database table and successfully uploaded these values into the database table, right? So we have 100 students in a student table, and we have around 10 on 8 departments in the department table. Now we have successfully populated the value, we have successfully basically confirmed that values are okay and values are correctly uploaded. Now let's assume that in future there might be some possibility that some of the departments goes down, or some of the departments shut down. So one or two departments which are now closing you need to take care of the values in the department number attribute of department number attribute in the student table, right? So because we are now, we have to remove, we have to delete some department number or some columns from the department table, because one or two departments are going down, right? So in these cases, SQL system will not allow you to delete the database values. Database DBA system will not accept any delete expressions from the parent table, because we have defined this foreign key constraint in the child table, and it is referencing to a parent table. So what we can do, right? That's one possible question. You cannot modify it manually, right? So that's how, and that's why we need some kind of constraint. So let me discuss this concept of on cascade, right? So on cascade is something, yeah. So here, so on cascade is something which takes care of basically uh, this scenario, right? So let's take again the same case, like in this expression example part, we are trying to create the simple till here, till this part, we are trying to create a simple database table student with these attributes: first name, roll number, and primary key and roll number, and department number. Then foreign key, department number, reference to the department. So till this point, things are clear to you, I hope, right? Now if you see these two statements, on delete cascade and on update cascade, right? So we have added these two phrases. So the implication of these two constraints, this constraint on cascade and on delete cascade, is simply will be actually, this is simply defined for taking care of the possible updation on the values in the possible updation on the parent table and its cascaded effect in the child tables. So let's assume that this D number is this department number from in the department table has been modified, has been deleted, has been updated. Now you have to take care of the effect of updation of these values in the parent table. So in the database, wherever this D number is used, which we are modifying in the department table, wherever this D number is used, its effect should be reflected, right? Effect on some deletion, effect on some updation. So whenever we were performing deletion or updation on some D number value in the department table, it should be reflected. That's what the ideal case, right? So that's why we are having this clause on delete and on update cascade. So it means whenever we are deleting the parents table value, whenever we are updating some value on the parents table, its effect will be reflected. Now you have to define what is the possible way of reflecting the change, right? So we have two possible cases and we have two possible options to be mentioned. So you can carefully see if we mention that while creating the database while creating the child table, you need to mention this thing. For key, this is basically assumed as a single line. So from foreign key to cascade. That's why we are not marking any semicolon, right? Colon or semicolon, right? So this is like foreign key D number references department D number. Then you need to see on delete, right? This part, and you need to see on update. Now on the occurrence of delete, on the occurrence of update. So for both you can have possible options, right? So on the case of deletion on the parents table, if you need that whenever we are deleting something in the parent table, you need to set the respective values in the child table as null. In that case, you can have here in the place of cascade, you can see on delete set null. This value you can see. So you can simply say on delete. Here you can have set null. So whenever we are deleting something on the parent table, in the child table you want to make these values, those D number values in the child table, in the student table, you want to make them null. That's what you can achieve. Similarly, if you want to set, like in case of any update on the parent tables attribute, you want to set some default value, right? So that you can define. So in the place of cascade here, you can have few alternatives, right? So like on delete, so you can have cascade, you can have set null option, you can have set default. Similarly for update also, you can have cascade, set null, set default. So these are like parameters, right? So whenever we see simply, whenever we mention like on delete cascade, on update cascade, it means whatever change we are performing in the parents table attribute, the same changes will be occurring on taking place in the child tables also. So let's say कि आपने department number 1 को 11 कर दिया, तो department number जो student table में जहां भी 1 था, वो सब 11 हो जाएगा automatically. So this kind of updates will be reflected because we have opted as a cascade. So whatever change is happening, it will be immediately reflected. Similarly, in the case of delete, so if you are deleting some department number, so whole tuple will be deleted. That's one part in the department table, and respective department number values in the student tables d number attribute will be removed. It will be set as a null basically, right? So if you select cascade, it will perform all the changes as it is, whatever changes we are doing in the parents table, right? And if you set other way, like on delete set null, on delete set null, on delete set default, that is up to you, right? So this is a very important concept. So ideally it is suggested that whenever we define a foreign key, you need to set, or you need to plug these two constraints, right? Because this will ensure that there will be no loss of integrity between these two tables, right? Because it is ideally requested to always have referential integrity between two database tables, right? So I think till this point things are clear, right? So you can confirm. If you have any doubt on this, you can immediately raise this question, right? Because this is a kind of important uh, concept, right? So I don't know why I'm not getting any queries. So let's take one particular question to see uh, how basically this will take place. This whole concept of on delete cascade. So there is a specific question I think plugged. So these are the typical other expressions. So we will take these expressions later on. First, see this question. So I think you can read it. Let me reduce the size. Okay. So it said that okay. So it says that there is this table. Yes, the following table has two attributes A and C, where A is a primary key, right? So if A is a primary key, naturally C is a foreign key, and it is referencing to A, right? And C is a foreign key referencing A with on delete cascade. Now this is the typical description. Now if you can see the values, the next instruction is the set of all tuples that must be additionally deleted to preserve the referential integrity when tuple 2 4 is deleted, right? So when we delete 2 4, what are the other tuples that needs to be deleted, because the on delete cascade is given. So can you tell me the answer for that? Can you tell me? Yes, can you tell me the answer?